All right, welcome back. This is Module 4 of Advanced Prompt Engineering for Journalists. I'm Joe Amditis, and I want to take a little bit of a different track for Module 4. In Modules 1, 2, and of course 3, we sort of took a linear progression. We started with an overview of why you should be out of the chat window on the web and why you should be into the CLI or the command line interface. Then in Module 2, we cranked it up a little bit, and I showed you some of the ways that these tools are really superior on the computer that you're using versus having them on the browser, and how they can bring in and collect massive amounts of information and then process that information right on your local machine. Module 3 took a little bit of a different or more intense track, and I want to reel us back in a little bit to the core of what we're trying to do or what this course is about, and that is advanced prompting techniques. So instead of doing a long demo of showing me working on these tools in real time, we're going to hit on 4 or 5 really core elements of how you can interact with these models, some key patterns that constantly emerge regardless of which model you're using. So let's go ahead and jump in. The first thing I want to talk about is effort and thinking. Now, this has gone back and forth a few times, and people have really been confused about what these mean. You can see here that mine says we're using the Opus 4.6 1 million context with high effort. And if I hit /effort, I have an option to go with low, medium, high, max, or auto. And if I type in max, that means that it's going to exert its maximum capability with its deepest reasoning, and it only applies for this session. And the part of the reason for that is that the higher effort or the more work it says it's supposed to do, the more tokens it burns. It's the same thing if you go into usage and you go to your configs and you go down to, where is it? Fast mode with Opus 4.6, it's going to burn tokens like crazy. The more compute that this thing throws at your problems, the more expensive it's going to be and the quicker you're going to use up your session limits. So I just want to make that very clear from the top, because I don't think that that's necessarily always something that people intuitively understand. Another thing I want to talk about is context. Now, recently Anthropic updated their maximum context window for Sonnet and Opus from 200,000 tokens to 1 million tokens. And you can see that up here, 1 million context. But in reality, nothing else seems to have changed about the models. And I think it's a good point to bring up when we talk about what context is and how to manage it. So if I look at my context here, I can see a little diagram at the top, all the way up here. I can see a diagram that shows how much of this window is used up, and we can see what part of my setup here is taking up those parts of the context. Number 1 is my system prompt. There's nothing I can do about this. This is basically the hard-coded instructions from Anthropic or from OpenAI or Google that is in every single prompt. You cannot get rid of this, and it only really takes up 0.7% of the total context. The system tools, that's another baked-in thing that we can't change, another 0.7. Custom agents. These are specific instructions and basically configurations that we have either given to the model and saved as a config for things like data assessment and data cleaning, code review, security audits. There are all kinds of ways you can customize your agents. They're basically skills that live inside of an agent that you can call with its own context menu. Next up is our memory files. We've covered this before, but this little red guy is taking up 0.8%. These are the lessons.md, the rules.md, the memory.md files, and of course, your Claude.md file, your core memory file that you use at the top of every project or root of every project folder, the root of your user folder, and of course, anywhere else that you put one. Then, of course, we have our skills, which are essentially just additional memory files that are loaded at the beginning of your conversation or when it is relevant. They are injected via hook, or you tell them to use the skill, you tell the bot to use the skill, and that context come in. Mine are set up so that I have a few of them that are loaded at the beginning of the session. These are called session start hooks, because I want to make sure that every session starts with these skills, especially when I'm in a particular project or folder. So that can change from conversation to conversation. Then, of course, we have our messages. We've already sent somehow 2,000 tokens, and all I've done is set the effort to max and change the usage. So we've already eaten up, just from this, already eaten up 0.2%. Then of course we have our free space and the auto compact buffer. The model will automatically compact and condense your previous conversation history as much as it can when you use the /compact tool or when it reaches this much of the context window used up. Now, what they don't tell you is that the failure point, even though they extended the total context per conversation before it compacts from 200K to 1 million, the model's responses and the quality of those responses still, in my experience and in the experience of other professionals who are using these tools, still start to degrade past the, I'd say, 20 to 30% window. Once you get past that initial 200,000 token context limit, you will start to see a noticeable degradation in the quality of the outputs that these models give you. So it's really important to keep an eye on that. And if you're like me and you've set up your status line down here, if you've asked it to set up your status line, you can tell it to put in this status line so you can always see it exactly how many tokens or what percentage of your total context window you used up. And so as you get closer to that 20, 25%, 30, 35% context or token usage, that is when you are going to really want to start thinking about compacting. So to start fresh, and you can do that in one of two ways. You can do /compact and just run that, and it clears the conversation history, but you keep a summary of it in the context. And you'll see that. Let me go ahead and resume a conversation and we'll compact one. We've used about 5% of the context, and I'm just going to say compact. Okay, so it's compacted the conversation, and the first message I send, you'll see this should update as soon as it starts the response. And it should probably go down to about 1 or 2% because it still has some of that context still in its memory. There we go. 3% used. When we last left off, we were doing a varicrypt format, blah, 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 blah. Now, if I look at my context again for this conversation, I scroll all the way up, we've compacted everything. The other way you can do this, let's do a different conversation. This one is a bigger one now. This is me trying to figure out how to stream things to my TV from VLC. And you can see this one has 13%. So the other way you can compact, other than letting it automatically do it, is you can add custom summarization instructions. And all this does is this gives the model an idea of what kind of context you want to preserve in that compaction summary. So VLC information and streaming configuration or configs. Now I'm sending a compact message with an additional bit of information that tells it what type of material it's trying to preserve in that summary. So this can help in small ways, but it can be really useful if you have really long running conversations and maybe the model is performing well and you are getting good responses, but you're starting to get up to that point where you're worried that it's going to start to degrade. So just to be safe, you want to compact, but you want to make sure that it focuses on the particular tasks or jobs at hand. And you want to just a little extra nudge to make sure that it keeps that up. So that's how you can do it. You give it a little additional message at the end and it'll reformat that summary. And we can try to take a look at that summary when it's done compacting by pressing Control-O, and it should show the full transcript that it has. And you can see here, we can see the conversation was compacted and press Control-O for history. And there we go. So this is the full record here. We have our conversation compacted, and here is the conversation compaction summary. It's being continued from a previous conversation that ran out of context. The summary below covers the earlier portion of the conversation. And you can see here that it has a lot of information saved about VLC remote access. Now, I'm going to blur some of these sensitive information here, but you can see here that it's saved basically a memory file of its own about all the errors and the fixes that we did, our different problem solving approaches, and then it has a full list of all of the user messages and the pending tasks. It also saves the full transcript of all of your conversation in JSON-L format on your machine. And you can see here where mine is. And if I just highlight this and I copy it, if I open up a new Explorer window, I can see that every one of my conversation, including the ones with subagents, all of this stuff is saved here. And then there's an index file. This is really useful to know, and I don't think a lot of people understand that this information is saved. If I go back to my conversation history here and I tell it this is a large one, if I copy the path here and I come in here and I say, tell me about this conversation, it's going to go ahead and it's going to read the transcript. So a lot of the times when people are using these tools, they don't understand that all of this stuff is being tracked. This is also important from a security perspective. And it's part of the reason why a lot of people will tell you to not just dump environmental secrets or tokens or API keys into the terminal, because that output is saved. So this is what I mean when I talk about managing memory and managing context. They work together. It's a one-to-one thing here. While you're also constantly updating and building your Claude.md files or your agents.md files and so forth, and you're making sure that you're using memory, you're using files as your context, you also have additional full transcripts available on your local machine that you can refer back to if you need to.